Okay, so last time we were talking about the if statement, and we're going to continue talking about the if statement. Last time we basically covered the majority of how to use an if statement actually. I did an if statement, I did an if-else statement, and then I did an if-else-if statement, which in Python is an elif statement. So, to make sure that we're all on the same page, let me go ahead and sort of review what I showed you. So I had this really fancy drawings and this control flows, and so an if statement is basically a decision point. And what you want to do with the decision point is be able to run different codes depending on what that decision is. And of course, that decision is just an expression that has booleans in it and statements and or not, and that's how you decide. Like if something is true and something else is true, then the statement or value is true, so you go to the true side, the true branch. If something is false and the thing evaluates false, then you go through the false branch, and so on. And you know, you might have situations where you want to run more code when something is true, but when something is false, you just don't run any extra code. So that's when you use just an if statement. When you have code that you want to run when something does not become true, along with it becoming true, then you have an if-else statement. If you only have code that you want to run when something is not true, but then when something is true, you just run nothing and then just keep going beneath it, then you can still just use an if statement. You don't want to use like an if-else and then just put nothing in the if block, because all you have to do is just flip the logic for the else. So let's actually start with kind of explaining what I'm saying with that. So suppose that you have a variable in Python, and this variable contains false. Okay? And that false, you know, right now I'm assigning it, but let's say you do some really fancy calculations to actually come up with that false. If you have an if statement that says something like if bar, first of all, one way that you could do this, but it's not really ideal, is you could say if bar is equal to true. And you can run some code, and that code is going to run when bar is true, and even else, then this code is going to run when bar is false. So in this case, because bar is false, then you would be running this code. However, the first thing that I want to do to optimize how I'm running this code is, if this piece of code runs when that statement is true, but bar itself can be checked if it's true by just doing this. So you don't need that. That's the first optimization you can do. You don't need to check whether something is equal to true, because you can just say if that, because if it's true, then it's going to run there. Okay? So hopefully that makes sense as to why that's the case. But more importantly here, if you have, if you're writing code like this, where you have if something is true, do this, else do this. If it just happens to be that you don't have any code that you want to run here, so you have code after the if statement that you want to run, and you have code for the else clause, but if like it happens that this code here, there's nothing to do there, you could do it this way, but you still need to put something in here. Otherwise, the code will not run. It'll get confused. So if you ever have an if statement or something, and you want to put an else, but there's nothing to put here, maybe there was at some point, but you removed it, but you don't want to change the if statement, then you still got to put something in. So what you put in there is a pass. The keyword pass in Python is just sort of like an empty statement, and you just sort of put it as a filler so that the if statement works. It also is used in things like functions and loops and other things we'll talk about in the future. But it can become very useful when you're writing code to sort of put it as a placeholder as well. So all it's going to do is be an empty statement, but in this case it's going to help because now the if statement is complete. There always has to be something here, and that thing has to be tabbed, right? You have to have that tab that we were talking about here. So you always have to have that. So in this case, if you're writing code and you intend to write things later here, but right now you're just kind of prototyping and writing it as you go, then you have to put that pass in there, okay? So it's just an empty block. You can put as many passes as you want. Literally in the middle of your code, you could write a line of code that says pass, and it does nothing. It literally does nothing. It's just an empty placeholder. Okay? However, In this case, if what you really have is this code, and this is like your final version of the code, where what you're trying to do is just run code when something is not true, and then when it should do nothing, then you can actually simplify this. You can turn this, I'll put it here, by saying if something, I'm not going to put it there yet, bar1, actually, since I made it uppercase, I'll keep it uppercase. Run that code, and then you have your leftover code. So this is your leftover code. And this is the if statement code. Now, the way I get this to work is simply writing a not here. If not bar, do this. Because doing that will do the exact same thing as putting it in the else clause. In fact, if I decided to add an else here, there's some code here, that would be the same code as here. But of course, there's nothing there, so the whole point of me flipping it is just to get rid of that. So this is that logical sort of critical thinking that you have to do. So if you only need to do something in the false branch, all you got to do is flip the logic of the if statement to say not something instead of this, and that will basically flip it. Another thing you could do is you could have written this as saying if bar1 is equal to false. That would have worked as well, the same way. However, I think this one is a little bit cleaner and more self-documenting and easy to read. But, you know, I mean, this is also readable, but it's just nicer. Okay? So, you don't need the else clause unless you actually have code on both sides of the branch. Okay? So, that was the if-else statement that we did. And then we went a little bit further and said, okay, what if we want to do multiple checks? What if we want to check something, and if that doesn't work, do another check, and then do another check, and then finally have like a fallback check. Like, okay, if all fails, just do this code. That's where your elif or else if. So else if in most languages, but Python and Bash, I believe too, elif is how you write an else if. It stands for else if. And so with that one, what we said was that, you know, we first do the if check. The if check is always going to happen, and you're going to check for something. And if that evaluates to true, then you go for the green code, you run that code, and then you skip all the way to the end of the entire statement. So all the way to the purple code at the bottom. You do no more checks. No more checks are done. The only time that you do the else if check is if the first if statement is false. So if the if statement is false, normally you would go to the else statement. However, here, you don't. You do a second check. You say, else if, check this. If this is true, then you go and do the red. And then after the red, you skip all the way to the purple. The purples, so every time you go into one of these branches, you do that branch, and then you skip all the way to the end. You do no more checks, no more branches. And of course, if both the if statement and the else if statement are both false, then you have your fallback as the else. But you can have a lot more. So right in here between this, you could have a lot more. So just to quickly show you what that would look like, although I'm pretty sure most of you understand that, I'm just going to do a very quick example by copying and pasting this. And really, what I want to do here is, let's get rid of that for now. And let's bring this down like there. And now I can basically put in as many of this else ifs as I want. In other programming languages, like C++ and Java, they have something known as a switch statement, which allows you to do these like major, like if you have 100 different checks you want to do at once, a switch statement is nicer. Python doesn't have it, so there's no point in me talking about Python switch, because again, those don't exist here. But you know, just be aware that there's better ways to do this in other languages. Although, you know, this will be okay. I mean, it's not particularly bad, but it can become a little convoluted. So here's an example of a relatively large if statement. I'm not even going to draw the control flow for this because it's just too big. But you do the if statement. If this is true, Like if that evaluation is true, then you're done. From green, you go all the way to the bottom. So from here, you would literally go all the way here and keep going code from there. Otherwise, if the if statement is false, then you do this check. If the check is true, then you do this code and then you go again all the way to the bottom. Okay? However, if that is false, then you do the third check. So you do this one. If this is false too, then you do the fourth. And you keep going and checking each one in that order, by the way, in the order that you specify, until you either go into one of these when it realizes it's true, and then after they go to the end, or you keep going. And after this check, which is the last else if this is still false right here, then you just run the else clause. So you will always run this if none of the statements are true. This is like your backup code. Okay? And then, of course, you will always run this after whatever you do because this is not even part of the if statement. So that's just an example of a really big one. So when would you want to do this? Well, suppose that you're doing data analytics and you're trying to find out different water quality levels, okay? I don't know what the scale for the water quality levels are, but let's just say that they're like letters, like A, B, C, D, or F, like grades, okay? Well, let's say that you have a variable called grade that has the quality of the water as a string. So it could have something like an A in it, but it could also have a B, a C, or a D, or F. So you could say in the if statement, well, if grade is equal to A, so you could write that as your if statement, if grade is equal to A, and then put it in there. And then maybe you do some code if the grade is equal to A, like you do extra science, or you just print out some really cool statement, etc., etc. But maybe now you want to check if the grade is equal to B and do different code on that side. Well, in the else if, you could write something like grade is equal to B, and then do some other code related to specific science that you want to do with B quality. Otherwise, you could do some specific science with C quality by saying else if grade is equal to C. Do science there. And you could do the same thing now with D. Don't forget your colons though. Very important, otherwise the code does not run. And so on. You could do this forever. Obviously, it's a lot of writing. So I would copy and paste on the computer, but even then, it's kind of not very nice. I mean, hopefully there's ways you can get around doing something like this, but could work. Actually, from D we go to F, right? At least in the school system. I don't know in water what they do, but yeah. Okay? And then of course your else is like, what would you put there? Well, you could make your else be the F if that's your last grade, because you just assume that like, well, if something is not A, B, C, or D, it must be F. So you could do that. However, you could also do the check there and then just leave the else as like something that says like print error invalid grade or something. You could do something like that too, and you could do your error check in there. Or if you know for a fact that like the grade is always going to be valid, you could actually do the F as the else, because like if it's nothing but this, then it has to be this, right? Like if I'm saying I'm thinking of a number from 1 to 5, and you guess 1, 2, 3, and 4, and I say that none of those are true, then the by deduction, like the number that I was thinking of was 5. So you can make that your else clause, because if you say, is it number 1? No. Is it number 2? No. Is it number 3? No. Is it number 4? No. Well, else, then the number has to be 5. So I don't even ask you anymore. I know that it's a 5. So that you could do the same thing here and make the else be the F. But you could also do like some sort of error checking if you're not for sure that it's going to be the case. Okay? And then the code down here could be unrelated to the grade of the water. It could be just, or it could be things that you have to do anyways in all scenarios, right? So suppose in all scenarios you want to print out a statement that says the quality of water is this grade. You could do that in every single one of the red lines, or the blue or the green one. But that's unnecessary to write repetitive code. It's harder to update and harder to change. So if all you want is like some statement that says what the quality of the water is, then that's something you would do either before or after the if statement. And you would just do something like print water quality level colon space, you use concatenation, and then just print out the grade, which is a letter already, so you don't need to do any casting. So you can do something like that, and that code will run regardless of what the grade is. So like that makes sense as to write either before or after the if statement. It doesn't have to be part of the if statement, because otherwise you have to write that like, sure, you could write something like, you could hard code the quality level in the print statement. You know, like if I did a print statement here, that was like C, like that, and then put that in the if statement for the C. So like this one here, I could do that, but you know, why? You have to do like 5 different of these and unnecessarily write extra code when you can just write the one here like this and put it either before or after the if statement, okay? So it's another thing to make sure that your if statements are only as big as they have to be. Things that are shared in common between branches, you don't need to necessarily do inside of the if statement. You can do outside of it, okay? However, what if like there was some code that I wanted to run whenever the grade was like A through C, and then some code that I wanted to run when the grade was D and when the grade was F? Well, there's a couple of things you can do. If all of the code is common between grades A and B, then you just combine A and B together and say something like if grade is equal to A or B. But the way you write that properly in logic would be, and this is one thing that throws people off a lot of the times, is you don't, you might see, oh, okay, let me just go ahead and say A or B, but that's not good. You don't want to do that. That won't work. And if it does, you don't want to get into that habit. You want to say A, grade is equal to A or grade is equal to B. Okay? You can't make the assumption when you say or B that you're comparing with grade. That's just going to value to true, because B is just going to be a value, and that value is not going to be 0, so it'll come true, and then or statement means that if one of them is true, so it'll always be true, and it'll be misleading. It'll be a semantics error. So what you want to do is something like this. Grade is equal to A, or grade is equal to B, or something else and something else, but you still write both sides of the comparison. So if you do something like this, now you can just run code that's common. So you could do that. You could do that as a way of combining different branches if the branches is the exact same thing. There's no reason to do 2 if statements. However, suppose that some of the things are shared, but not all of them. Like maybe you do some signs specific to A and B, but then there's like, that is common. So like maybe like 3 lines of code are common, but then like two lines after that are not common. They're independent of each type. So there isn't really an easy way to do it as I'm showing you here to be able to do things that are shared between common branches. You either go all the way or nothing, right? It's like an everything or nothing kind of situation. However, there is a way that you can get that done using nested if statements, which is what I have up here as the topic. So how do we do a nested if statement? Let's look at our control flow for the basic if else if statement. Let me just copy that down here. So right now, I have a situation where I do if something is true, run the green code, else if that else is true, run the red code, and if it's false, run the gray code. However, in this case, you can think of this as being if grade is equal to A or B, right? And then this is going to be else if other stuff I don't care about, like C, D, and E. But what I want to do is I want to split what is on the green, because like if I mix colors here, so let me pick a red, well, not red, just yellow. So in here, the first piece of the code is shared between A and B. But then this code here is unique. So it's either A's code or B's code. So my question is, how can I take this piece of code and split it so that I run unique code for each letter along with common code? And the solution to this, like I said, is going to be a nested if statement. So you're going to have something that says something like, again, if grade is equal to A, or grade is equal to B. And then inside of that, instead of putting the 5 lines of code, so line 1, line 2, line 3, and like I said, the other 2 lines are the lines that we want to be unique to A or B. So this would be like A's unique lines, and these are B's unique lines. So A and B both need to run these 3 lines, but then these are A's lines, and these are B's lines, right? So because I want to make those unique, all I have to do is make another if statement inside the other if statement. So like if statement inception. So I can put the first 3 lines that are common, run those, but then I can say if grade is equal to A, run that. Otherwise, run that. And I don't even need to do an else if there, because I know for a fact that the only way that I could have gotten into this inner if statement is if the grade was A or B, because I checked it on the top if statement. Therefore, if the grade is not A, it has to be B. There's no doubt about that, because of the way that I have the if statement up there. And so now, you basically have common code here, but you can also have unique code to each of your specific scenarios. So if I update this to kind of reflect that, it's going to look a little weird. Let's get rid of this arrow. We're going to get rid of this from here. So we're running the 3 lines, common there. And then we're going to have another if statement here. And this is like if equal to A, and this is your else, which is just equal to B. Okay? So that will be the equivalent of this here. I'm trying to get it all on the screen. Hopefully that makes sense. So the trick to doing an inner if statement is you have to tab it further. So again, the normal if statement here, you have this tab, and that's how we know what's inside the if statement. In fact, technically speaking, all of this code is inside the first if statement, the outermost if statement. It's all tabbed the same. So your if here, the if, and the else here are aligned to the other statements, the A and B statements, okay? Then internally, you have a second sort of tier of tabbing right there. For the inner if statement, like that, okay? And so basically, your if else are lined up to the outer if, but these are lined up to their own sort of statement. So this and this are all lined up, nice and straight there, okay? If this code runs, because there's no code after here, the next line of code that's going to run is whatever would be down here. So if there's some code down here, that would run after this runs, or after this runs. But you never have the situation where both of the green shade would run both at the same time. Like either one or the other is going to run, and then it's not going to do the other one. Other than that, I just want you to know that you don't have to stop here. You could go and make 10 layers of if statements. You could say like if, I don't know, if X is true, then do that. And then like you could have if Y is true, go do that. If C is true, go do that. If 2 is greater than 1, go do that. And so on. And you could have an else if in here too. If is 2 is equal to 2. I don't know. and so on. Although in this case, you've got to make sure you have some code in here. Say pass for now. And as you can see, every time you have to tab it more and more and more. And it can become very tricky in other languages that don't require you to tab things. But in Python, you don't have to worry too much about this. To line up your ifs, because like, okay, suppose here that I run an else. Some languages that don't require tabbing, if I throw this in here, you know, and again, some languages don't require to tab things. Whose else is this? Like, it could be the else to this one, it could be the else to this one, it could be the else to this one, or it could even be the else to this one right here, right? And this is known as the dangling else problem. It's a computer science thing. You don't really need to worry about it, but just be aware that it exists. The reason why you don't have to worry about it is because in Python, the tabbing matters, right? And so the tabbing is going to tell it. If I tab it here, then it's going to be this if statement else. If I tab it here, then it's going to be this if statement else. If I move it here, then it's going to be this if statement else. And of course, they all do completely different things because they're they're going to the else of that, or that, or that, or that, right? So, you know, two things to take out of this. Make sure you line up your else or your else if in the right spot, because the same thing could be with the else if. Right now it's being taken as here, but if I move it here by putting less space, now it's actually this else if, right? So the spacing matters in Python, and in this case, it's actually really useful to avoid issues. Places like C++, where they don't have the spacing issue, they use curly braces, but you only really need to use curly braces with an if statement if there's multiple statements inside the if statement. So like if there's multiple lines in here. So this becomes actually an issue for the interpreter to figure out, and I believe that it just shortcuts it to just doing the closest one. So like it will go with this one. But yeah, it's a problem for you, not a problem, because other than making sure that you actually space it and line it up correctly to the right if. Another thing that you can hopefully start to appreciate here is that your code can get really spacey when you're writing a bunch of nested if statements. So like in this case, you can see that I'm starting to run out of space. If I wrote 10 other if statements, I would literally need to like allocate more space above me so I have enough space, right? Because like I'm running out of space horizontally. This becomes an issue with like really complex Python code, that it's just so horizontal code because of so much tabbing when things are nested, when you have something inside of something inside of something, that like it's just really hard to read sometimes. And so there are some practices to avoiding this. We're not gonna bother covering them because we're not gonna get to that kind of level. You just kind of handle it by scrolling left and right, you know. But be aware that this becomes a bit of an issue if you have logic like this. Now, one of the solutions to that, which you should just kind of be aware of, is that it's about good coding and good logic, thinking before you code. Do you really need to have all of these if steps like this? You know, can't you compare, combine, or flip logic around to avoid this? And the answer might be that yes, more than likely you can do some level of it. Because what you're doing here is you're saying that this piece of code that I'm about to highlight, the pass here, even though there's nothing, but you're supposed to did something, this is only going to run if this is true, this is true, this is true, and this is true. And of course, the reason you're doing this is because hopefully you have, for each of these ifs, you have some other code that is run in common. If you don't, then you could combine this and say if x and y and z greater than 1 and 2 equal to 2, putting all that as one if statement in the way that I said it, you could actually write that pass, and this would not be super horizontal anymore. But of course, if you have code that runs when x is true and y is false, then you can't really do that. So, you know, there's a lot more to this, but I think this is more than enough for your level. Yeah, even if you don't write the most beautiful code, it's okay, as long as the code works. That's the most important thing. So, yeah, that's nested if statement, and it can be very, 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 very useful to simplify your logic and to just make it more easy to function around this. So as you can see, it's always a good idea when you're starting to program to draw these pictures to kind of understand the flow of the program. It might not be so obvious when you're looking at something like this versus something like this with drawings, but everybody's different and everybody has ways that they can understand things better. But don't be scared to use nested if statements. They're actually there to help you make your code easier. Anybody have any questions on them? Let me actually move this here so I can see the chat better. Okay. Hopefully it's all very straightforward. Is there any other important thing I want to talk about nested if? Not really. Not that I can think of. So, okay, let's move on then. So, one of the things that I wanted to talk about on Thursday's class was the list data type, but I don't want to jump in because we're about to finish the time. So maybe what we can do is let's do some coding examples of this. Yeah, I think that's going to be better. So you can see some examples of using an else if statement. So let's switch over to coding. So here we have the example where I was just checking whether a number is greater than, equal, or less than. So that is fine, but let's make something more interesting. Let's just make sure that everything is running. Okay, it's running. Cool. So, let's do the example with the. Let's do a school grading, because then at least that one I know they use letters, right? So let's say that you're trying to calculate somebody's letter grade based on their percent. Okay, so like grading scale. So the first thing that you might want to do is store what the percent was. So like, let's say that you're trying to figure out the letter for somebody's percent grade. Okay, so let's make a variable called grade and assign it the input. So somebody asked, like, enter your percent grade. Okay, and that's just going to store a percentage. Although there are ways to sanitize and remove the percent. We're not really going to bother too much with that. So we're just going to assume that the user is going to enter two numbers, and they're going to be a percentage from 0 to 100. Well, I guess three numbers if they get 100. Okay, and then for now, let's. This will be stored. If you remember the last videos, one of the things that we ran into was that when you read something in from a user through the input function, it returns it to you as a string. We want to convert it to a number using an int function here that is going to convert this string into an int. So we probably want to do the same thing here. Now it's a number. Why do you want it to be a number? Because you want to do, you can do math with it. You can say whether it's greater than or less than something. We can't do that with a string because it's cars. Okay, so now the grade is a number. So we can move on to the if statement. Now, of course, you could do a formula and get this done in 2 lines with a formula, if you do a formula correctly. But we're going to do this the simple way. So we can say, if grade is greater than 90, I don't know grading scale. We're going to do an easy grading scale like 90, 80, 70, 60. I don't want to do some fancy stuff. So we're going to say if grade is greater than 90, then we can add more code later, but now we'll just say you got an A. Okay, so we can do something like that. Let's just test it so far. It's always good to test to make sure things are going. First thing I see I don't like is I want to put a comma like that, colon. But let's just try putting in a 100 and see what happens. You got an A. Okay, so it's working. And then I space this out, so next time I run it, you'll see a little space there. Of course, if I do the percentage, you know, it's going to break it because of trying to convert, you know, it's trying to convert the percent and think of it as a number. So, like I said, for now, we're just going to assume that we're taking clean numbers. At some point later in time, I can show you, once we learn looping, then I can show you how we can loop through each of the characters and verify whether they're numbers or not and remove them if they're not. You can use a function called, like I believe it's called isDigit, and then you can basically remove the non-digits out of there and then clean it up. So yeah, you'll learn that, but for today, that's not the focus. So we'll just assume that every time you're entering a valid number from 0 to 100 inclusively. Okay? So this, you know, if you want to do your else if now, you can say if else if grade is greater than 80, you got a B. Oh, forgot to write my print. Now, here's something interesting about this. If I write an 81 or 84 here, it says I got a B. And if I write right now for like a 70, it says nothing, right? Because I haven't gotten there yet. Here's something interesting that I want to make sure that you understand. This check has always been run before this check, right? That's why this works. If I flip these around and put the 90 down here and the 80 here, so like if I take this code, you know, I could actually switch it to an if, and this would work the same way right now. It's just not very efficient code, and also you're going to see something interesting happen. If I put a 91, it says you got an A, and it also says you got a B. You see that? So the else if allows you to not do this check if this if else is true. Furthermore, the order matters. If I try to flip this up here, like that, and then put the else if here, like this, then technically speaking, if somebody gets a 95, it's going to run this and it's never going to run this. You see that? So the order of your checks matters. You want to make sure that that logic is sound. This is what I just showed you right now is kind of part of what's known as a fist bus question, and I'll show you that example at some point. But it's the best way to catch someone that just knows very basic coding from somebody that at least knows some form of coding, because you can know the syntax of how to build an if statement and how to do checks, how to do logic and whatnot. But if you don't have that sort of critical thinking practice, then you will do that kind of mistake, and then that's how they would detect that you're new at coding. Not that that's a bad thing, but it's just kind of neat. So I'll show you FizzBuzz, or you can Google it at some point. But anyways, you know, just to wrap it up, we'll just make our scale be basically anything less than an 80 is a fail. Okay? Yeah, we'll just do that. Actually, no, let's do one more. Let's do one more because I want to do something here. So we'll do 70. It's less enthusiasm, first an exclamation point, then a period, and then just 3 dots, I guess. Passive aggressiveness. And you failed. Okay. So right now this is set up kind of decently. But so here's the thing. Suppose that you know, for a student to pass this specific class, and I believe that's the case for grad students, right? You need to get a B or better, right? So we wanted to also print out a statement that says you passed the class. Right now, we would have to print the statement twice. We would say something like, here, you would have to say, you passed the class. Actually, I want to put that after. Makes more sense to say that before you tell them the grade. Right? But copying and pasting, not good, especially because like here it's just one line, but like you can think of this line could be 100 different lines in your program. So while this works fine, if I say 88 says you pass the class, and if I say, you know, 71, it says you got a C, and if you say 55, it says you failed. So the question is, can I combine these two? And yes, you can do that using the nested if statement. Okay? So what you can do here is you can, well, there's a lot of things you can do. If you just want to write this statement after this, you could write an if statement beneath it that says like if grade is greater than 80, then you can say print you pass the class. Okay? So this is one way that you could do that. That would work. And it would print it in the right order. Like that, without repeating code. If you wanted to show the statement above the grade, then you can put it above, and it would also work. Okay? This would be actually probably an ideal way of doing this to avoid that horizontal issue. But you could also do it with that nested if statement. So you could say, if grade is greater than 80, well, I should have just pasted what I had, but you can just put that. And then inside of this, you can put in the nested if statement. You can put your else like that. Because you don't really need to do the else if. And every check you do is more work for the computer. So, while it's very, very tiny, you still want to optimize your code. And also write less. But you could also do something like this. And this is a nested if statement. First you check if it's greater than 80, which means you pass the class. And then if the grade is actually greater than 90, you print out you got an A. Otherwise you print out you got a B. You print it this way. You get an 87, it says you pass the class, you got a B. If you want to print this after the grade, then you can just move it down here. Just make sure that this is lined up to here. If you line it up to here, then it's only going to run when a person gets a B. Here, it's going to run as part of the first check. And if you somehow did this instead, then this is no longer part of the if statement, and then this is all confused because it's like it does not see an if. As you can see, that's why it starts to get underlined with an error sign. But if I do that, then it'll work okay. As you can see. Or, if I do 100, it should still be okay. All right. Different ways of achieving the same thing. Which one you choose to do depends on how you have your code organized. So the nested if statement can be useful, but be careful about it a little bit. Don't go too excessive with the if statement because, like I said, it can become really horizontal, and then you have to scroll not just vertically like up and down here, but you have to scroll sideways to be able to read code. And I'm guilty of that as well. I'll show you some code at some point that you can see where, yeah, it gets pretty wide, especially when you're trying to print all these messages. So, yeah, just thought I'd show you an actual example where the code is running. And of course, if we, just for fun, let's run it with a debugger. So you can see that. So let's say that they got an 81. So you go into the code, it checks that, it enters that, checks this. In this case, 81 is not that, so it goes to the else clause, runs that, then it runs the print statement, and then you see that it'll skip all the way, well, to the end, but there's no code at the end. So, yeah, versus like, here, let me just write a code at the end so you can see it better. Thanks for checking. If I run this now, and this time I give it like a 70, it goes there, but the grade is not greater than 80, so it goes all the way to the else if. In this case, 70 is not greater than 70, so it just goes all the way to the you failed, and then runs that. One more run. Let's do a 91. The 91 is greater than 80, so it goes in there. 91 is greater than 90, so it goes in there. It runs that, and then from there it skips the else, goes all the way to the you pass the class, and then goes all the way to the bottom. And after that, it's done. So, really nice to see the debuggers because you can see the flow of the program. Also good in case the output isn't working, you expected something else. then it's easier to see like where it goes wrong, and you probably see why at that point, or at least can tell me like, hey, it's going wrong here, and then I can figure that out too. So that's it. Like I said, next class I will be showing you some lists and maybe start talking about looping. So looping will be a very, very powerful tool as well. So that's it. That's all I have for today. So be sure to check out the next video for Thursday, and then we will catch up next class. All right. Thanks everybody. Thanks for watching, and I'll see you guys next time. Take care all. Bye.